video if you guys want to look back at it. You know what? So just for the video, if you wanted to look back, remember it's row times column. It has to equal, just in case it loses your memory. So you do those two times those two. Switch the page back would equal the 39. First row, second column would be the 39. And here we did the second row times the second column, and it would equal that 38. So in case you want to look back at the video that I'll post with this. Okay, so solving equations is first we take a system of equations that's written X, Y, or whatever, make sure that they're in order like they're supposed to be, and we turn it into a matrix equation. And the way you do that is take your 2 and your 6, just the coefficients, so you get a numerical matrix, and multiply that with the variables you want. So they would be X and Y, right? So if 2 and 6 are your row, then X and Y have to be the column. So if I multiplied those two, I would get 2X plus 6Y, just like matrix addition or multiplication tells you to. And that would equal another column with that equals 22. First row times the column would equal first row column. So my second row would be 6 and negative 3, right? 6 and negative 3. So that 6x minus 3y equals 24. So this is a system of equations just written in matrix form. Now, I want to know what X and Y are, so I need to get rid of this matrix. Like I said before, we can't divide matrix. You can't divide that out. So what we do is use what's called the inverse of this matrix. And there's a whole explanation for this, but we're not going to worry about getting too deep into it. But if you take the inverse, which is this matrix to the negative 1 power, it's just like if you did 5 to the negative 1 power, you would get 1/5. It does the reciprocal. So anytime you multiply something times its inverse, you get 1, because that would be 5 times 1/5, and you get 1. Well, in matrices, when you multiply the inverse times the matrix, you actually get what's called an identity matrix. 1, 0, 0, 1. And the reason it's called the identity matrix is, if you think about it, if I was going to multiply row times column, I would do 1 times X, which would just give me X. And then in this one, I would do the 0 with the X and the 1 times the Y, which would just be Y. So this identity allows us to drop it out, just like we do the 1 when we're solving equations. Well, if you do something to one side of the equation, and this is the important part, you have to do the inverse first. You have to do the 2 by 2, 2, 6, 6, negative 3, times the 2 by 1, 22, 24. You can't multiply it after because it won't line up, right? A 2 by 1, you can't multiply by a 2 by 2. And the inverse is still a 2 by 2. So it's the inverse times. So all of this explanation isn't really needed if you go from here to this. It will give you XY. So let me show you in Desmos. If we go back, open up Desmos. Where are you? Math tools. So the matrix calculator. So I'm going to do matrix A was, now I got to look back, but you're not seeing me look back. 2, 6, 6, negative 3. So 2, 6, 6, negative 3. And then your second matrix will be 2 rows with 1 column with the 2 solutions that were 22 and 24. So 22, 24. So once you have those in, it is A, and here's your negative. You have to do the A first because this only gives you a -1 power times your B matrix. So 5 and 2 are the solution. So I would go back here. So I know that X equals 5 and Y equals 2. So, like I said, all of this was just explanation, but it's really quick solving these matrices. And I'll show you, like with a 3x3, if it switches. Can you hear my dog's little toenails walking all over the floor? He's antsy for some reason. Okay, so you have a 3 equations, 3 variables, 3 solutions. So in the matrix calculator, you would do 5, -3, -6. So X, Y, Z, X3. If it doesn't have a number, it's a 1. So -1, -5, and then 4, -2, -1. Don't forget you have to do it to the -1 power times the solutions. So go over to Desmos. Clear all the old ones out. New matrix is a 3x3 now. And it was 5, -3, -6. So 5, -3, -6. Okay. Hold on. Get out of there. Nope. Crazy dog. Okay. And where was I? 3, -1, -5. So 3, -1, -5. And 4, -2, -1. 4, -2, -1. Into that new matrix, it would be a 3x1. So it's a column with your 3 solutions, which is -4, 5, -13. Enter that. And then you type the same thing every time. A to the -1 power times the solution. That's it. And it's that quick that you can have the X, Y, and Z. So much easier. Could have been doing this in Math 1 the whole time, but they won't teach that in Math 1. -2, 4, -3 are the 3 solutions. So say -2, 4, -3 are your X, Y, Z. Questions on that? Sorry about the dog. He wake anybody up? Good, good. Okay. So I have more examples. I'll do one. Well, let me see what the other ones are. See if one's better than the others. Nope, nope, nope. Okay, we'll just do this one, and I think you'll get the idea. So what I was going to show you, if one of these is missing, if you don't have an X, a Y, or Z at all, then use a 0 for it. Now, if you have the variable without a coefficient, it's 1. But if the whole thing is missing, if this just said 5y minus 6z, without it, you'd use a 0 there. So in this one, your 3x3 would be 5, -4, 2, 1, 5, -6, 1, 4, -5, to the -1 power, solutions, 21, 24, 21. Put that in Desmos, and you have your answer for X, Y, and Z. So go to your Desmos, clear all, new matrix, 3 by 3, 5, -4, 2, 5, -4, 2, 1, 5, -6, 1, 5, and 1, 4, -5. Enter that matrix in, start a new matrix, which is a 3 by 1, and it was 24, 21, 24, 21. Into that matrix, and again, don't just hit the, because that you have to have the matrix name first. So it's a to the -1 power times b. 5, -1, -4. So, so the answer is x equals 5, -1, -4. And you're done. So very simple to do, very quick. And those are the last 2 questions on your quiz tomorrow. So your assignment, you come back over to our class. I won't do the last one because I think you get the idea of, but the assignment itself is 8 of them. I know it says 19, but 1, 2, 3, 4, 5, 6, and then 7, 8. And like I was saying here, like in number 19, use a 0 for the Y because there's no Y in that one. All right, let's, where's the stop